Alright, in this video we're going to take a look at solving inequalities. And for the most part, until it comes time to interpret these things, you can just treat an inequality like it's an equation. We can just kind of pretend that this thing here says equals, even though it really says less than or equal to. And then at the end, we'll interpret our answer accordingly. But right now, mechanically speaking, just pretend that says equals. So let's use our typical algebraic process, what we've been working on as a habit so far. I'm going to subtract 5. Because that's the number that is not attached to the x, so I'm going to get it out of there first. And that gives me 3x equals, we'll just pretend it says that, 6. Last step, I divide by 2. So I end up with x is less than or equal to 3. Now that's my mechanical answer. We need to figure out what that really means. Because if you think about it, how many numbers are really less than or equal to 3? Well, lots of them. In fact, there's a never-ending amount. So instead of writing every number that's less than 3, we're just going to draw a little picture to show what that is. So I got this number line out to the side. What I'm going to do is I'm going to take my number line and I'm going to number it 0, 1, 2, 3, 4, 5, -1. Okay, you put some numbers on there and you just kind of put the numbers in it that are around the value you got right here. Now what I want to do is I want to color in the numbers that actually work as a solution to this. So I want to color in everything that's less than or equal to 3. So I'm going to put a few numbers on there that I know are. What's less than 3? Well, 2 is less than 3. 1 is less than 3. 0 is less than 3. Basically everything to the left of 3. What about this? Will 3 fit that statement? Is 3 less than or equal to 3? And the answer to that is yes, because I have that equal to portion right there. That's telling me that it could be equal to 3 or it could be less than 3. So 3 works also. So I'm going to color in this circle that's on 3. That's my boundary. That's kind of where the solutions stop. But I'm going to color it in to say that it works too. 3 works and so does everything else this direction. So I'm going to shade that way. And by shading in that line and putting an arrow, I'm saying every number this direction works. And there's a whole bunch of them here that we haven't even written. All the little decimals and fractions that are between 3 and 2 and 2 and 1, those also work. So we're coloring it in rather than listing everything out. Now, let's take a look at another problem that's basically the same thing, but there's one little trick to watch out for. In this problem, I'm going to treat it the exact same way. I'm going to subtract 4 because it's really a positive 4 right there. I'm going to subtract 4 over here. So I end up with negative 2x. Notice that negative is still there. It's still attached to the 2. Negative 2x is less than negative 10. And I'm going to divide by negative 2. Divide by negative 2. And in a later time, we're going to go through the y of this. Right now, I'm just going to tell you how. Anytime you divide by a negative number or multiply by a negative number, somewhere in the process of solving, if you ever have to divide or multiply by a negative number, so essentially, is there a negative number attached to the x? And if that's the case, then we are going to have to flip this inequality so that we don't change what this thing means. When we get back to plugging in some numbers that work or don't work, then I'll be able to explain why. But for right now, we're just going to look at the mechanics. X, I flip this sign right here because I divided by a negative. Doesn't matter how this answer turns out. It's only if you divide or multiply by a negative. And that's going to give me positive 5. So let's look over here at how that would look on a picture. I'm going to start with 5 and I'm going to put it right there. So 6 is going to go here, 7 goes there, 4, 3, and so on. And now let's look and see what we could do here. What's a number? This one says x is greater than 5. Remember, that's like a little Pac-Man there. It's going to eat the bigger number. What's a number that's bigger than 5? Well, 6 is bigger than 5, 7 is bigger than 5, so I can see my solutions are going to the right here. What about 5 itself? If I put this in there, 5 is greater than 5, does that make a true statement? And the answer is no. It doesn't have the equal to portion like the problem we had up here. So it can't be equal to 5, it can only be less than 5. So I'm going to leave this circle open. That circle tells me my boundaries here, but it also says, hey, 5 doesn't work. Okay, in this problem up here, 3 happened to work, but here 5 doesn't work, so I'm going to leave the circle blank, leave it open. But I'm going to color everything this way to show that all the numbers to the right of 5 that are bigger than 5 do work. Okay? And like I said, at a later time in class, we're going to work on why we have to flip this sign so that it'll help you remember it. But for right now, just remember if we ever divide or multiply by a negative number somewhere in the process of solving, we're going to have to do this.